So I ran out of battery power in my last video, so I'm going to be putting it into the next one. So this one's going to be line 18A 3z2b7b6, and then we're going to go back to line 18A 3z2b6 to finish filming that. Actually, the title of this one is Solar Neutrinos Flux Redshift Spectra 8b PP Chain Sun Curvature 5G Wow Seti, and the other one was T2K Super-Kamiokande Neutrinos Sparticles CERN LHC NCPIOs 5G UFO Wow Seti. So I have to go back to the line where, for part 157, we're talking about the collisions, and it stopped here, so I'm going to start here. So I googled T2K neutrino, and it brought up the T2K Tokaikamaka Japan is a particle physics experiment that is in collaboration between several countries, with Japan, Canada, France, Germany, Italy, South Korea, Poland, Russia, Spain, Switzerland, and the United States, and the United Kingdom. It's a follow-up of a T2K experiment. It's based on neutrino oscillations, and the J-Park facility is going to produce an intense off-axis beam of muon-neutrinos. It is directed towards the Super-Kamiokande detector, which is 295 kilometers away. Its main goal is to measure the oscillations of VU to VE, to measure the value of V13, and one of the parameters of the Ponto-Koro-Maki-Nakawaga-Sakata matrix. And June 15, 2011, the T2K collaboration announced the observation of 6 electron neutrino-like events compared to an expected background of 1.5, a significance of 2.5 standard deviations. And here's some pictures for you to look at. That's the graph of where it was. That's J-Park, and that's Super-Kamiokande. That's what it looks like. That's the map. It's to investigate how neutrinos change from one flavor to another as they travel during neutrino oscillations. They use an intense beam of muon-neutrinos. It's generated at J-Park Nuclear Physics Site on the east coast of Japan, and it's directed across the country to Super-Kamiokande neutrino detector in the mountains of western Japan. It is measured once it leaves the J-Park site using the near detector ND280, and again at Super K. The change in the measured intensity and composition of the beam is used to provide information on the properties of neutrinos. Their goals are listed on their website, T2K Experiment.org. So I'm not going to read all that stuff now because I'm just going to bypass all this. I was going to read all this before, but it's too much information. It's talking about the T2K experiment, the detector, what they do, how they analyze it. You can look at their website. And Paul Gazowski has a PhD thesis, and he's talking about the reconstruction of NCPOs produced in the trackers with both photons converting in the downstream calorimeter, developed purely with Monte Carlo, with Genie as the interacting generator. And it's applied to the first year data. I think I pulled this because it was a PDF. It also talks about tracking charged particles, which can be detected through photon conversions in the electromagnetic calorimeter that surrounds the tracker. And let's see. Yeah, so he's talking how to track certain types of neutrinos, which I know they have problems with at times. You can take a look at his thesis at www.t2k.org. Doc thesis 013. And this is a Super-Kamiokande 4. This is a T2K beam run 40 spill. Shows the charge numbers, and it's got the things there. It's the first 2TK beam neutrino event since the earthquake of March 2011. And these results are from 26th of January 2012. That's when they were published. And it shows the event display above has a Cherenkov ring produced by muon in the center of the image. This muon was produced when a muon-neutrino in the T2K beam interacted with a neutron or proton in an oxygen nucleus in the water of Super-Kamiokande. Detection of this event is another major step towards resumption of data taken by T2K, and they're going to be starting again in March 2012, where they'll be doing some more testing. Okay, and so they mentioned the Kamiokande Observatory, Institute for Cosmic Ray Research, University of Tokyo, and there's a quote definition: a ring imaging Cherenkov. I didn't know exactly what that was, so I looked it up. It's called a rich detector. It's a particle detector. It can determine the velocity, or V, of a charged particle. It does an indirect measurement of the Cherenkov angle, the angle between the emitted Cherenkov radiation and the particle path. So there's the calculations that they use, where c is the speed of light and n is the refractive index of the medium. Okay, I'm just bypass that. It works in Max Terzero's Luzizi group in Delphi. Cone of shadow of light is produced when a high-speed particle transverses a suitable medium, often called radiator, with a velocity greater than the speed of light. My thoughts, February 26th. So if I read this correctly, according to the T2K results, it says that a ring imaging Cherenkov detector was created by the particles in a muon, with the neutrino experiment showing that they are traveling faster than the speed of light in their calculations. Am I right or wrong here? According to this quote from Wikipedia, it says the cone of light that talks about its travel faster than the speed of light, okay? And I know there was some problems with the one at CERN. They said they did travel faster than the speed of light, and then they said one of the plugs weren't plugged in properly. That came out this week. They had some problems with their wiring. And then they also had another thing that wasn't plugged in, and they're saying that actually it should travel faster than the speed of light again. So they're going to be doing some more testing. And this facility says that they've tested, and they're stating that it is traveling faster than the speed of light. So obviously they have a way of making them travel that fast. Okay, so this is the first muon-neutrino disappearance study with an off-axis beam. This is a PDF file I found from January 6, 2012, and it was published February 22nd, 2012. So it was published about a week or so ago. They're saying they report a measurement. Sorry, the author is K. Abe et al. At the T2K collaboration. Okay. So he says, we report a measurement of muon-neutrino disappearance in the T2K experiment. The 295, just so you know, all the experiments that I've looked at about the neutrinos, they send so many to the collision area. Once they collide, some of the neutrinos are disappearing. In fact, almost 50% are disappearing, and they don't know why. So this is his report here. He says the 295-kilometer muon-neutrino beam from Tokai to Komoka is the first implementation of the off-axis technique in a long baseline neutrino oscillation experiment. He talks about data corresponding to 1.43 times 1020 protons on target. We observed 31 fully contained single U-like ring events in Super-Kamiokande, compared with an expectation of 104 plus 14. So obviously they wanted almost 3 times. If over 3 times the amount they expected to have, they only had 1/3 of it. Events without neutrino oscillations. The best fit point for 2 flavor. Okay, I don't know what these calculations mean, so I'll just let you look at it for your boundaries. 90% confidence region. So that's his calculations. Again, you can read this on the American Physical Society site at link.aps.org. There's the link there. I'll post it for you on the blog when I blog the video on Victoria Stafford psychic investigation. That's where I'm currently blogging my UFO alien stuff, as well as ghost stories and stuff like that. So February 26, 2012, my thoughts. Again, based on the T2K experiment results, the measurement of muon-neutrino disappearance is as follows. You have 1.43 at 1020 protons on target. We have 31 fully contained single U-like ring events in Super-Kamiokande. compared with an expectation of 104 plus 14, plus or minus 14 cyst events without neutrino oscillations. I say the neutrinos don't disappear. They just split into 4 quarks, and 2 of them are smaller than the originals, so they could be splitting into another 4 quarks, and because they are much smaller, you haven't detected them yet. If you can spray a mist of water on them that is a bit warmer temperature. Also, put an organic material on the neutrinos before you start your test to make them turn into Sparticles. Then you can read the flashes of light. Slow down the camera shots and see if there are any types of flashes of light going on during the experiment. Zoom in on the flashes of light and use infrared or redshift to view them. That's just my ideas. I don't know if it'll work, but it's a suggestion. Here's the tags for this video. So that was the end of part B. The next video is part C, which is the original one that we were starting to film. Okay? So I'm going to start filming this one here. There's our Wow Seti alien signal. Google Neutrinos Redshift Spectra. Again, all this data is based on line 18A, 3Z. And then I broke it down into different videos. This was another 9 videos based on a comment about electric universe. It wasn't originally in the Wow Seti signal, but it is part of the, it's actually bringing up stuff for the Wow Seti signal. I call it the Wow Seti signal because the data that came up in it has to do with spaceships, stars, old stuff, new stuff. Basically, we're finding a lot of new inventions and patents with this data. Okay, so a new PDF file came up, Relic Neutrinos in the Early Universe, from Olga Mina Fermilab and G. Barenboim and C. Quigg. It says the location of these origin lines in the UHEV spectrum points to neutrino masses, integration over cosmic time redshift, CMB neutrino temperature. So basically those are the keywords that came up with that. This is the 2-mass galaxy catalog. It says Redshift catalog. I grabbed it on this website, scienceblogs.com. I just wanted to show you what it looked like. And then this blog post mentions the solar neutrinos in redshift. I was researching redshift, trying to find out what it meant. So standard solar neutrino energy spectrum, the energy spectrum of neutrinos from the pp chain of interactions in the sun as predicted by the standard solar model. So there's the super K, there's chlorine and kellium. This is the Bacol Pincinel 98. Neutrino energy, MEV, and then it says neutrino flux. I have no idea what it means. It looks like it somehow creates more energy. There. So the energy spectrum of neutrinos from the pp chain of the interactions in the sun, as predicted by the standard solar model. Again, when I find a keyword in the video, I look at the definitions of it, I look at graphs of it, because I want to understand the concept, see what it means, and see what I can find to create a new formula with the data I find, okay? So this is neutrino fluxes from continuum sources, such as pp and 8b, are given in the units of count per centimeter squared per second. The P chain is responsible for more than 98% of the energy generation in the standard solar molar model. Sorry, I'm having trouble talking today. Neutrino produced in the carbon, nitrogen, oxygen, CNO chain are not important energetically and are difficult to detect experimentally. The arrows at the top of the figure indicate the energy thresholds for the ongoing neutrino experiments. And it says from the paper, this is from the paper Solar Neutrinos Where We Are Going. Okay. Again, that's from www.nss.ias.edu. Yeah, I'm really having trouble talking today. There's the rest of it there. So I found the best estimate standard 8B neutrino spectrum, that symbol, together with the spectra, it's hard to see it, allowed by the maximum of this theoretical experiment and uncertainties. And that's, I can't even read this stuff. Neutrino energy, obviously it's spiking. So I Google redshift wavelength solar neutrinos and see what comes up. I've got this view graph in figure 5 from the paper Standard Neutrino Spectrum from 8B decay. Again, we're looking at the way particles decay with neutrinos to make them split more and make them decay in a certain way so that we can split those ones that are decaying as well. I don't totally understand everything, so please bear with me if I get it wrong. And here's a book that's from Curvature Cosmology, a model for a static stable universe by David F. Crawford that came up with the data. He wrote it in 2006. It says the next topic is to consider the effects of curvature redshift in our own galaxy that is observed at both radio and optical wavelengths. The redshifts could differ. Even closer to home is the topic of solar neutrinos, or more particularly YS. They're doing a lot of testing on solar neutrinos right now. There's another PDF file that came up, the Journal of Cosmology. It's of solar neutrinos and curvature redshift. Can explain the anomalous wavelength to an individual photon. They are properties of groups of photons. Again, those links will be up on the blog. February 28, 2012, my thoughts. In 2012, they are studying the effects of solar neutrinos in relation to redshift. Finding these PDF files and reading them, it may shed some light for you to look at and test the theory, since it came up in the Wow Seti lines of data here, based on a comment in relation to electric universe. So we're going to Google electric universe and redshift spectrum and see what we find. So the data found is, quote, "What Big Bang? Synopsis of the electric universe," from www.holosilence.com. The redshift of a distant galaxy is measured in the light coming from that galaxy. Lines in the spectrum of that galaxy show a shift towards the red compared with. And then the next thing that came up was Hult and Arp's discoveries about redshift, electric cosmos. That's from www.electriccosmos.org. Says if the lines in the spectrum of the light from a star or galaxy appear at a lower frequency in the spectrum of the sun, we say this object exhibits positive redshift. Moving things in the observed universe, but they are among the youngest. Again, that's from a Google search. So, quote, redshift and blue shift. So we found another color that's coming up too. It refers to the change in frequency of light. When an object shifts away, it turns red, from and towards, it turns blue, the center of the potential energy. Red shift and blue shift show up in light spectra patterns from objects. They are two kinds of shifts, gravitational and electric, due to the gravitational and electrical potential energy. The shift is measured by the cos of the angle between the radius of the potential center and the velocity of the object with respect to the center. If the angle is 90 degrees, then there is no shift, or the shift is 0. There's the calculations there. If the angle is less than 90 degrees, the shift is red and the object is moving away from the center. If the angle is greater than 90 degrees, the shift is blue and the object is moving towards the center. At 0 degrees, the object is radially moving away from the center, and at 180 degrees, the object is radially moving towards the center. At 90 degrees, the object is moving transverse to the center. The redshift is the ratio of the speed v of the object to the speed c of the light, and is designated by this. And then you have a gravitational redshift, which is that. Then we have an electrical redshift, which is this calculation here. Find structure constant. And it says the redshift indicates that the direction of the object velocity is away from the center, and it indicates the object is in equilibrium between the centripetal force and centrifugal force. The redshift is misunderstood by scientists and it indicates an expanding universe. So I found this in Wiki Answers. This guy is saying that they misunderstand redshift and they're saying it's not an expanding universe, although science says it is. And there's our tags for this video. And all these videos here, of course, are on the same thought pattern, so you want to watch all of them. Okay. So they've been divided into 9 videos, and this is basically based on one person's comment called Electric Universe, and I got 9 videos from it. Okay, so I'll go on to the next one then.